Yes. So we will take a slow start, so to say. I just need to fix HDMI here. Laptop. The laptop. Mhm. So let's see. Now, yes, nice. Okay. Hi, everyone. Who doesn't know who I am? Of you who are sitting here. You? Good, good. What program do you not know? Yeah, you know me. That's good. That's good. Nice, nice. Okay, so I think with most of you, if not all, we met last year in the in course. No, not with you. I guess you're a little bit confused about this statement in the course about knowledge management and representation. So this year we will dive into another aspect of AI. So we will be talking about AI in general, what it is all about, and to narrow down the scope during today's class. But now, for those of you, just to be sure that you are in the right place, we are in course D7041E, Applied AI, which focuses on aspects of learning. And I will tell you now the scope very soon. So we will be talking about learning and some applied aspects of it. So how to make it efficient. So what approaches exist out there beyond or apart from deep learning and backup methods. And yes, and this is a very practical course where you will try lots of things um, in labs. Well, I will not repeat the extract from the syllabus, so that this you can read offline, obviously. The course material, well, historically, in fact, this course that you're taking now, it was I think, amongst the first courses developed about machine learning in our department. So it is active for almost 10 years now. And as such, well, there is a great book, this Artificial Intelligence, a Modern Approach. You can always use it as a reference, absolutely. The main, and apart from this, there are plenty of resources in the internet. Obviously, you can use and you should use um, to go deeper in certain directions. But the main material will come from lecture classes and practical assignments. So there won't be any quiz or such. There will be set of lectures and connected to them labs where you will try these different aspects in practice. And the whole course consists of labs, seminar, and mini project as examination moments. No final exam, no quizzes, nothing like that. Now, in the first half of today's class, I want to go through logistics of the course and just explain you the rules, how we will work during this course. So here are the thematic modules on the top row that we will be talking about. Well, traditionally, this course is taken by people with very mixed background. I know some of you are very good at machine learning using libraries, Python, and such. Some of you, well, still in progress. For some, I mean, certain topics will be totally new. And to establish a common ground somehow, so the very first module, so which will begin during next class, it's fundamentals.
Sorry for interrupt.
Yes, sure.
We don't see the screen if you are sharing.
You don't see it. Okay.
There is no screen sharing.
I thought I pressed the button. Sure. What about now?
Now we see the screen. Yeah.
Well, thank you. Thank you. And please, yes, even in the future, unmute yourself and speak up because I normally don't see the chat messages. So you still see my slides, right?
Yes. Yeah.
Good. Thank you. Yes, to establish a common ground, so we will go into most important aspects of fundamentals, so pre-processing and such. And believe me or not, even as of 2024, there are people in the area of machine learning who are not as well, at least not very careful with this step, or even put it in another way, not systematic or not paying enough attention. Also, this is the most important step towards achieving accurate, statistically correct results when evaluating a learning algorithm. And this also will constitute a large part of the mini project. I will very soon come to the idea about mini project, but one of the lessons to learn from this is that we will work with some standard data sets, which are used for benchmarking different classifiers. And even in this kind of almost standard data set, so they use very different approaches to pre-processing of data. And if you are not careful or not taking into account what is going on, then it will be very hard to interpret the results. So we will spend a little bit of time talking about it. And the whole idea, the thematic layout of the course, as I mentioned to you, so is to give you a wide spectrum of learning techniques, which are based on the concept of neural networks, but not only that. So as I said, we start with classical learning algorithms, classical machine learning approaches. We will look, next we will look at different kinds of embeddings achieved with neural networks and not neural network based. Then we will go into a topic which is actually a topic of my research, focus of my research. It is encoded here as HD. It stands for hyperdimensional computing. So this is a mathematically grounded way for constructing representations. Well, and I will give you a short introduction about HD already today. So this is an approach to create neurosymbolic like models. Next, we will go into unsupervised learning. In this module, we will talk about self-organizing maps. And by the way, so let us do kind of a little bit more interactive. So when I mentioned this approaches, so can you just raise a hand so if it rings a bell, if like word embeddings, distributed representations, which is word embeddings as well. So we will be talking about this. Then self-organizing maps. No? An interesting concept, yes. And then so after self-organizing maps, I go into classical multi-layer perceptron with backdrop, focusing really on the mathematics behind it. So why does it work and internals of the implementation. So the overall concept is that in this class, we do not use libraries, like not at all. So we implement algorithm, well, except probably for NLP module part of it. The idea is that you either will be given a stop code or you will develop a code from scratch, implementing a certain algorithm. So without using any framework. Well, of course, you can use NumPy. I mean, that's kind of, you cannot go without it. But for example, in the backdrop module, so it's I mean, we will not use torch or anything like that. So I will give you an implementation, like a matrix-based implementation of the backdrop in a simple setting. And the idea will for you will be to identify the operations, the functionality inside the algorithm corresponding to particular mathematical aspects of backprop. And then, for example, there you will try different nonlinearity functions and see that is actually very sensitive to choice of parameters. So that's the idea. In that lab, you will not implement anything. So it's more of kind of observational type. And all in all, in all labs, so the whole concept of the course is to give you a taste of time complexity, or when working with machine learning, AI learning. So you will see that most of the time it will be consumed by data pre-processing and such, and actually running the experiments. Practically, you will run experiments on your laptops, so no fancy stuff. So they are not large-scale experiments. Also, we will see how it will suffice for the mini project. But so all labs are doable by an average laptop on an average laptop. And time series. In time series module, well, apart from the problem formulation and overview of existing architectures, including LSTMs, our focus will be on yet another type of neural networks, which is called randomly connected neural networks, or reservoir computing. Does it ring a bell? Reservoir computing? So the whole idea, cool, nice. So then you will learn something new, I hope. The whole idea, or a side idea with this course, is also to give you a taste, or to show that not everything in AI is about deep learning. So there are other alternative learning approaches, more lightweight, which serves concrete purpose, which you can have at your possession for practical purposes. So here, I can tell you right away that this last lab about randomly connected neural networks, lab number 6, is the most time consuming. As an input, you will be given an article, well, actually a tutorial, but in textual form, about implementation steps, but not the code. The code you have to develop yourself. On this note, I don't know if I at least I put it in Canvas in many different places. Let me just open it. Labs. Yes. I want to emphasize this point over here. Well, it is put in a very kind of German way. It's, no offense to them. Strictly forbidden to use Gen AI to produce a code. So now let me decode it and put it in another form. I just I mean, talking about course development. So this is one of the course development moments compared to the last year. As I told you, this course was active for quite some years now, before ChatGPT era, and this problem never appeared to me as a problem. So when I say students develop a code, they develop a code, you know, just trying to do it, and then they come across interesting problems that they try to solve. But as of last 2 years, I see a I saw this phenomenon that this lab 6, which supposed to be the hardest, was no biggie for students, and most of them just presented the code and it worked without encountering these issues. And then I realized that most of the code is also kind of written heavily with the help of Gen AI. That's okay. I mean, that's the thing that we have to live with. But you know, a deeper investigation shows that people don't even bother looking inside that code from ChatGPT or whatever assisting program. And that's why I really, well, discourage you from blindly using the code. Sometimes it might not be even correct. I can tell you a story, my recent example of using ChatGPT, fantastic tool. I use it as anybody else. I think in the context of security course, I wanted to play around with the Galois field. You know Galois field, so the finite field arithmetics, like modular, but with polynomials. Nevertheless, so I wanted to implement polynomial division, symbolic polynomial division, and I was kind of lazy enough to write everything from scratch. So I asked ChatGPT to do that, and it produced a very nice looking MATLAB code. And actually, at first glance, it worked. I mean, it's supposed to do this stuff, but then actually the results were a little bit or quite discouraging. So, so the good thing is that I didn't start from scratch, but then I realized that they performed the division. So basically, using the shift in the wrong order somehow. I don't know why, and that's kind of ruined the results. So all in all, why I'm telling this to you, you know better than me. So if you use Gen AI to assist coding, don't blindly copy it. So I expect that you understand each and every line of it. But again, in the scope of this course, so try really to implement everything from scratch, starting from initialization of matrices, doing really basic implementations. And as for the implementations, again, my suggestion, use a linear coding style. So don't overcomplicate the stuff with object-oriented and such. So most of the tasks here, I think all tasks, they can be implemented as a linear program. So a body functionality and some functions, but it's really linear. So there is no need for complex interaction. So the simpler the code is, the better. Yes. So that was an introduction to labs. At this moment, I want to comment about the main communication channel between you and us. So on my side, I also have a teaching assistant. His name is Philip. He's a PhD student at our department. And he will be assisting you resolving the questions, practical questions with labs. Since several years now, let me double check the chat. So. Yeah, well, here, and could we use PyTorch only to operate with tensors? I don't see, okay. In many cases, again, the key word here, this course is not about deep learning. It means, as such, you will very seldom come across the need for working with tensors. So simple NumPy implementations would suffice. Even in the backprop module, so it is based on NumPy, just to keep it clean in the matrix form. But of course, you won't be punished if you use tensors. But again, I really don't see how it would simplify your life in Lab 6, for example, so, where you have a single matrix, like 2D matrix. Why to use tensors in this case? Yes, communication channel. So let me go back to Canvas. So I hope you all had an opportunity to log into Canvas and read the information. So all the labs are available from day one. So you're free to take them in any order. So you don't need to wait for the class if you kind of work in your own pace. Yeah, by the way, lab 3, it also requires our own implementation. And it's also kind of time consuming with respect to pre-processing of texts. So in lab 3, the task will be to classify language, determine a language of a written text. So you will be working with a database of 21 languages. And so you need to train a classifier for that one. But again, using non-deep learning approach. Yeah. Yeah, I was about, sorry for jumping back and forth, but I mean, ask me if I missed some piece of information. Discord. Since I think 2 or 3 years now, I use Discord as the main communication channel, except instead of using Teams. I don't remember if I used Teams in the previous course. Discord, yes. Okay, that was done before you. So normally it is appreciated by students. So this is the structure, and as in my previous courses, active participation in resolution of problems, technical questions of yours, would give you extra benefit, like extra points if needed, towards the end of the course. So please answer, be tech support for yourself. So and actually this works as best when you help each other. As I mentioned, so you have enough skills to resolve these problems. We will monitor the chats and interfere so that you, I mean, when there will be some stale situations, so that you all manage to complete the labs in time. But the priority will be given for your own answers. And so I already today, some of you, I don't know if you're here in the class, this is the disadvantage with the Discord. So you appear under some really funny names here. So that's, I mean, it doesn't allow me too much to particular individuals. But direct messages works fine. That's okay. But if your question of a generic character, like the one I received today about some particular task of lab one, put it in the corresponding channel. So I will answer, and everybody else will see the answer. So if you permit, I will I will copy the text of the question to lab one channel. In addition to this, this year, we plan to have regular Q&A sessions with TA, with Philip. Again, so this is something new we want to try. Historically, if I would go through course development, so we had purely physical labs, like people were sitting in lab rooms, and we were, running around and answering questions, to purely online labs during the COVID times because of obvious reasons, to online labs with peer review that was we tried last year. And this is because we have a mixed class, so we have some distance students as well here in this course. Nevertheless, so there were some wishes from the last year evaluations to have physical sessions, and we will do them. What to expect from them? So it will be like Q&A sessions. So come with some specific questions. I mean, those which are not answered in Discord, and so we will see how it will work. Okay. So yes.
So we do not present all.
No. It's more for really questions, some technical questions about labs. So again, the reason is, or due to the fact that this course is given both for students here in place and distance students. I canceled lab assessments, physical lab assessments. So I read the reports, and so the reports should be, well, there are some recommendations in Canvas, but a report should be annotated Python notebook, Jupyter notebook, so with the runnable code. So notebook, notes, the code, notes, and the graphs whenever needed, the results. So this is your report. About the working style. So you can work in group, but I expect that reports are individual. So that means that at least you bother going, through the steps, intermediate steps, and compile your own report. So, but of course, you are encouraged to work in whatever groups you wish. Yes. So let me check the. Can we use GenAI while creating the lab report? No, I mean, I'm talking about Jupyter Notebook, and it's about the code. So no, I mean, why would you need? I mean, if you want to correct your grammar and style, of course. I mean, that's not an issue. But I don't see how otherwise you can create it. I mean, all labs are about some questions to answer, and these questions require, for example, plotting a graph or given a number. So, and this number should be clearly visible. I mean, Gen AI wouldn't help you producing this number. All right. Emails. It's of course you can send me emails, but this is least preferable way of communicating to me because of this terrible number. I don't know if you see of unread emails, which I somehow managed to accumulate over the, I think, past 15 years or so. So, I mean, the risk that you end up amongst this terrible, or you will lead to increase in this number is minimal. I still read emails. But I prefer to, I mean, from my experience, there are no such questions that cannot be answered in Discord. Okay. Also about the specifics of lectures in this course. Only some classes will be given as presentations, as PowerPoint presentations. So there will be quite some classes I will use remarkable tablets to go through the math of certain approaches. Simply because I mean, AI at the end and learning, its learning part is about math and coding, as you may imagine. Yes. As for the labs, I decided this concept worked quite fine. So I have quite flexible deadlines or generous deadlines, so to say. But I don't want. I'm not very flexible with them. I'm kind of contradicting myself. So I said it at that place. No, but I mean, I'm generous with the time for labs, but I'm not very flexible. So there is a cutoff period for labs 1 to 3. This is simply to avoid, in the first place, to help you not to accumulate a backlog. So labs 1 to 3 have to be finished by December 6th. Only in exceptional cases I will accept late submissions. And labs 4 and 6 have to be submitted by January 3. Yeah, here it's written about the proof of work. Another examination moment is the seminar. This part of the course was modified several times through the history of this course, starting from very or rather boring, I would say, presentation of a group in front of a class, like you sit here, sleep, and these guys, they give a great presentation. Nobody cares, and but nobody asks questions, nothing. So that was the least successful structure for this moment. The most successful structure was a kind of mini conference where the presenters made posters, and I actually requested students to literally go from one station to another and talk about stuff. That was kind of most successful. To the current version, which appeared as a result of welcoming distance students, because I mean, distance students obviously cannot be physically with us and roam between stations. So starting from last year, I make it as a virtual event. So you will be, we will form groups. I tend to again, so I have to confess, I haven't decided it by the time I came to the class. Last year, I did random assignments to group, and when saying this, so I immediately get some. I was like, why random? Why should I? No, so I don't know how would you perceive it, but nevertheless, I tend to allow you to form groups as you please, like by groups of 3 or 4 people. I'm working on a topic, so it will be an article to review. The articles I will publish within the next 2 weeks. So you read the paper and you prepare a presentation, and you will present in Zoom. And it will be mandatory to attend some number of presentations. So and again, so since we are quite many in this course, so there will be some parallel sessions. So you can, it's not that you will attend all of them, but you should attend, I think, 3 on average. So and it worked fine last year. So and at the end, so each group will make a video recording, upload it, and then I go through the video recording. So I cannot physically attend all of the seminars, but I review them offline. On many of them, I try to attend personally. Grading, again, my magical number 300. So don't ask me why this 300. So it just my grades from the very first course I developed here. So so each lab gives you a number of credits. Where is that? 50, 50, 50. Well, I guess they all give 50 points, so they are quite equal. And so completing, well, scoring 150. So 3 labs give you 3. So and then what was it? 250 give you 4, and 300 sharp 300. So all labs completed give you 5 in this course moment.
Send them in,
Yes, you send the report in as a submission in there, so by the deadline. Mini project. So let's talk about mini project. So this information is available to you, as I said, from today on. So you can start looking at it. So for starters, I want you to read this article over here. Do we need hundreds of classifiers to solve real-world classification problems? This is from what is it? Yeah, from Spain and Brazil. Research in Spain and Brazil, but what we will be using there is this 121 data sets from the repository called from the University of California Irvine repository, UCI data sets. I mean, this UCI data set is very famous in machine learning and is used for benchmarking. So you can have a look at this article. So it gives some benchmark results, and this is something new. So for this year, the new thing is that as of this year, you will work on exactly the same problem. So I mean, and that's why you can discuss across the class how to what are your experiences and such. But I want you to try different supervised and unsupervised methods. This is up to you to choose. So and the grading criteria really depends on the kind of time complexity that you invest in the mini project. So I mean, let's start with grade 3. So those of you who just want to finish this course and forget about it. So you take one unsupervised method, one supervised method, one unsupervised method, and manually select 5 data sets and do the experiments and report on accuracy results. So for grade 4 and 5, so grade 4 and 5 actually is different mainly in the number of models that you have to use for evaluation. But for both grades 4 and 5, so you really need to do proper pre-processing, well, data standardization and such, perform statistically sound experiments with different seats, averaging. So most likely automating a script for using for running experiments, and plot the graphs and try different models. So that's up to you what to try. And then you always have to refer to the benchmark results. Yes.
So just to check that my understanding is correct, the mini project involves from us testing one model on multiple data sets to see how one model performs on those multiple data sets. Or more than one model, but one supervised and one unsupervised.
Or several.
Yeah.
Yeah, that's true. And here, here I was tempted to let me do the spontaneous change here.
Libraries
for what?
Libraries for this, or does it need to be from scratch also?
Let's put it this way. For example, you can use your code that you implemented in lab 6 and lab 3 and lab 4. So then, I mean, for testing on these data sets. So and then you can complement with libraries, yes, if you kind of know what explain what these libraries are doing. But again, so what you my point is that what you should try avoid by all means is to reuse existing implementation as just plainly, because I mean there is a code for different classifiers working on these data sets. Of course, I mean that's not the first time it's a data set, benchmarking data set. But do you use library or code developed in labs? The only thing I encourage you is to do manual your own implementation. I mean, of the experiment. So here, I would say 20 plus. Some data sets are really small. I think iris data set. You know iris, the classification of flowers with 4 features. Very fancy. I think it's part of this data set. Some of them are larger and using more features, of course. It is here you can come across the need for computational power, and maybe again, so you can try if especially when you target. I mean, I somehow like this concept of already kind of planning. I mean, which path you want to take, but the important thing is that for grade 4 and 5, or even grade 5, let's put it this way, maybe you can start writing a generic script, a script for processing all of the data sets, like 121. And then you will see that, okay, so maybe your computer is not powerful enough to do that. And then you can cut the number of data sets appropriately. All right, let's probably take a break at this moment, leg stretching. If you have any questions, so I'm here, so come and ask. And we resume in 4 to 5 minutes. Ja, absolut.
Första frågan är, man skulle använda helst koden från lapparna till ingen Python.
Nej, bara om du jobbar med CNN och liknande.
CNN, då kan vi köra Python.
Ja, men de datasets, de är ganska små. Det kanske inte behövs.
Andra frågan var kursen vi hade innan med dig. Vi hade 2 quizar.
Ja, data representation and management. Ja.
När går den?
Den är redan den går nu.
Den går just nu.
Ja.
Just nu.
Alltså du vill göra om quizar?
Ja, så man får bort det.
Ja.
Det går ju ändå 4:e året nu så det inte hamnar på 5:e.
Nej, men det, jag kan säga, det kan vara rummet. Rummet är öppen för alla, så det finns datum för quizet där. Men du måste omregistrera dig som kompletterande student. Och sättet att göra det är att skriva till EduSRT. Så skriv till EduSRT och säg jag vill omregga som kompletterande student.
Just det, okej.
Och då hamnar du inne i Canvas-rummet per automatik.
Okej.
Och då ska jag även se det i grades. Så kan,
Ja, perfekt. Ja, men då så. Jag trodde det bara skulle vara så enkelt att du bara slängde in.
Nej, eftersom det är quiz i Canvas så den är synlig bara för de registrerade studenter. Så du kan inte ta förra årets quiz, så det blir nu.
Ja, just det. Men då skickar jag iväg ett mejl.
Ja, absolut. Till EDU-SRT.
EDU-SRT.
Ja, som ett ord.
Tack.
Hej.
En fråga, men labb 6, är det random?
Randomly connected nu. Nej, det är en subklass av recurrent neural nets.
Okej.
Ja. Men det här nyckelordet är det slumpmässigt kopplade. Så man inte tränar själva nätverket. Så är de vikterna.
Jag lärde mig CNN och jag kollade upp CNN. Är det den?
Jo, så
Random är en subklass till.
det är subklasser där.
Okej.
Du kan också läsa, det finns so maybe so let's continue. Let's continue. Maybe just an extra information looking forward to the last module. So this RNN, so on the level of acronym, so maybe to avoid some confusion. So RNN stands also for recurrent neural networks, obviously. So and recurrent neural networks with backdrop are what? Like LSTM, right? And others, so we will be overviewing them, but that class that we will be focusing on, the subclass of recurrent neural networks, which are also called randomly connected neural networks. And there are two types of networks of interest in this context. One which is called echo state network, that's what we will be working with. And this class of network is used for processing time series. So whenever you have time dependency. Another instance of these networks for vectorized data. So it's called, well, it has a second name, extreme learning machines. So if you Google for that, you will find it. Let me see. All right, so let us start talking about or narrowing down the scope of the problem that we are talking about. And so this probably I mean, I reuse similar slides from the other course, but again, as part of recapitulation, what is AI and what part of AI we are talking in the context of this course. And on the next class, so we will even kind of do, during the next class, we will do taxonomy of different methods and just the learning branch of it. But nevertheless, so intelligent behavior, so behavior of biological intelligent agents, humans or mammals or even insects. So there are several of them, several essential behaviors that define cognitive abilities. Goal orientation. So that's, we do all our actions having a specific goal in mind, and we can assess this goal and we can do corrections according to this goal. And this kind of prevents us from kind of trying randomly all different variants. So and kind of make conscious decisions. Again, so another important manifestation of intelligence is reflection on complex and detailed environment. So this is already, closer to the subject of this work. So how to link an environment which is rich of details and otherwise would take a loss of data to describe to another level of abstraction. So basically to the domain of symbols and symbolic reasoning. So here we are not talking about just symbolic reasoning, but we want to have this link, the grounding. And symbols and abstractions, a very essential behavior, and one of the unsolved challenges of artificial intelligence, how to actually enable learning of this stuff. I have to make a remark. Of course, deep learning has a great success. I mean, this Gen AI is fantastic, and it can solve past Turing test and such. Yet it cannot. It can be shown that it cannot address all the problems of deriving symbols and abstractions and reasoning in full. So this is still remains one of the unsolved challenges on how to make a neural network to learn symbolic representations or abstract representations. If we would have time, or maybe I can use this time. Today we have this introductory class. I can cast this question on you. Do you have any objections to what I say? Or do you think that neural networks just fine in learning representations which can be used as symbols and abstractions? So what is challenging? Yes.
Have a picture. It's that maybe it can't understand all of them are chicken. Like that's the challenge, right?
Exactly. Understanding a world as part-whole hierarchy. So this is the challenging. For us, biological agents, intelligent agents, even without seeing an instance of an object by pure description, so you can construct its representation, which is matchable to raw sensory input that you would be exposed to this input. So the current development vector. Let me see. I think one of the mics is enabled. Mute. So the current development vector in deep learning, and that's why it's is basically using many examples to kind of derive more or less accurate representations. Yet, for example, a question of learning transformed objects. Well, if we talk about images or even signals, even like audio signals, so this still remains challenging. So neural networks have very hard time learning invariant representations. So that if you rotate an object a little bit, then it may be misclassified by given methods. The keyword here is also limited exposure to species. I mean, in technical terms, we are talking about one or a few shot learning, which again is possible with within the deep learning model. So like post training, but the question is at what cost? I normally give an example of this of honeybees with a very simplistic brain structure compared to humans, which are or yet are capable of learning abstract concepts in just few trials, like based on visual input. So modern neural networks, they have really hard time to match the same efficiency of learning. Another characteristic behavior of intelligent agent is flexible. Well, it's a flexible acting. So depending on the environment, and in general, it is about kind of having a plan. Well, I mean, this behavior can be translated in several AI mechanisms, starting from planning, but also kind of allowing a space for errors. So that's, I mean, if you have an error, so what it might be. So I mean, so this has direct implications to learning. And last two important behaviors are operation with large amount of knowledge and ability to derive new knowledge based on the experience. Here we are talking about complexity of a learning process. Again, so this behavior itself can be translated, and we did translate it into kind of complexity of knowledge structuring and navigating through the knowledge in the context of the other course. Here I make another interpretation of this behavior is that learning a specific phenomenon really depends on the context. So it should be a context-driven learning. In many machine learning tasks, I mean, where you have just, for example, a simple classification problem. So out of distribution samples, they are kind of, I mean, the result of the classifications would be unpredictable. In many practical situations, so you need to include other factors that, for example, help the model to classify one or another instance. And this is challenging when talking about learning. All in all, so this is a generic architecture of an intelligent system or agent that actually takes input from the environments through sensory system and well, possibly act upon environment. In this course, we are concerned about this link. So really learning from from the sensory input and see what kind of models exist out there. Yes. Talking about another important functionality of AI system is a process of taking decision. Again, in the context of this course, we talk about models that are executed in finite time. Given an input, we produce an output. So this is a deterministic algorithm. And that's what makes it different. I mean, makes a whole difference between machine learning and AI at large. In AI, we are talking about a continuous assessment process. So a process which never halts. So it's not a non-halting problem, and and it poses another challenge on where to understand that the system provides a solution. So, but again, so this is something that is not fully understood yet in the domain of AI, even with the existence of Gen AI and such. So as we talk about a continuous problem, so we are talking about algorithmically unsolvable problems. So can we achieve AI in this case? Well, that's a big question. So, and what I'm up to here, I want to first highlight the kind of intrinsic complexity of the type of algorithms that we are working with. So when we talk AI in this kind of its fashionable acronym form, we indeed talking about algorithmically unsolvable problem. So it should be a system of solutions that contribute to the intelligence. So not only a single model that can do everything. But also we are talking about computationally complex problems. And I want to spend just a few minutes to remind you about a phenomenon which is called curse of dimensionality. Or maybe you can remind me what this is all about. Curse of dimensionality?
The problem becomes bigger and bigger.
So yeah, and in which case the problem becomes bigger and bigger. So in what sense?
Complexity and the space.
Exactly.
High complexity is
Exactly. Time complexity. So let me first talk about time complexity. Again, given a taste of it on this very simple algorithms. So algorithm 1, so it takes 5 million operations for processing n-bit number. And algorithm 2, it checks if an n-bit number is divisible, I guess, not divisible, divisible on any other number. So checking if the number is prime. And it requires 2 to the power of n-half operations, obviously. So here is the linear complexity, here is the exponential complexity. So the number of samples that you need to, number of operations you need to produce depending on n. And here is a simple example of running this algorithm on machines with different frequency, operational frequency. So 1 gigahertz and 1 terahertz. So you see, and depending on the number of n, so you see that the second problem goes out of hand quite quickly with number of n. So this is a kind of a sensible example. And that's why I mean, very often when working with ML AI algorithms, I mean, you need to keep this in mind, the number of iterations you do. And for example, when studying the effect of a growing dimensionality of the algorithm. So for example, that you will see in the lab with self-organizing maps. So self-organizing maps kind of explaining on fingers. So you have a lattice of neurons, like specially arranged neurons. And this lattice can be of different size, and depending on the size, so you can have one or another accuracy. And then you have a learning algorithm on top of it. And then, so experimentally, so I'm asking you to experiment with different sizes of these lattices. So it actually varying n. And then you will see how the execution time goes very quickly up, so that it might take several hours to complete. So don't be surprised, or even maybe as a hint, when you do implement ML algorithm, insert some execution monitor, because I mean, if you click and you just rely on this rotating thingy in Python in Jupyter, I mean, you never know at which stage of the algorithm you're currently are. So this is one thing of time complexity, as you said, exactly. But then there is a complexity connected to a special complexity of the problem. So the phenomenon that you try to characterize through observations, some observations. So this is a data-driven modeling we are talking here. And each data point are the characteristics of a certain phenomenon. So another word is feature or variables, talking in mathematical terms. And there is a huge difference if we talk about, say, 10,000 observations of three-dimensional case versus, say, 100 observations of, or 100 observations of 50-dimensional case. In what sense? So three-dimensional case, so you have three variables. I mean, we are in 3D. So you want to characterize any 3D shape. And you do 10,000 measurements of the shape. So most likely, these measurements would create, you know, would allow you even to approximate the shape. Versus a high-dimensional space. So 50 features is already high-dimensional. In many cases, especially in image processing, we are talking about thousands or million-dimensional spaces. And here, you know, 100 or even 10,000s of observation would appear just as scattered points. I mean, you just don't sample enough the phenomena. So, and that's why. So, in many, I mean, to have a representative model. So this is the reason why deep learning is so heavyweight. So we need lots of examples to get a representative model for this number of dimensionalities. Another example. So now more to connected to classifier. So this one. So we are talking about nearest neighbor classifier, very advanced one, but apparently I mean, it shouldn't be discarded at all. So you will be working with the KNN classifier in the first lab. K nearest neighbor. So you have a huge memory of samples, and then you determine the nearest one according to a chosen distance measure. And we are about to learn a Gaussian distribution with some number of dimensions. And so for 4 dimensions, so I mean, the 44 samples in the memory is enough to kind of accurately reconstruct it. And for 128 dimensions, so you need these many observations. I mean, again, for accurate reconstruction. Later on, especially in the module about which I kind of mystically encoded as HD, I will be talking about an opposite phenomenon, which is also called a blessing of dimensionality. So, and it is about very interesting mathematical properties of high-dimensional representation spaces. Again, now I'm waving hands. At that moment, I will show you some graphs and give you some more formal rationale behind it. But in high-dimensional spaces, if you decide to do your learning in high-dimensional spaces, it has very specific properties that allows to build simpler classification models, for example. And I will kind of approach this problem through or this property of high-dimensional spaces through support vector machines. I don't know, did you learn about SVMs in other courses? Like the details, the math behind it? Well, let's see. So SVMs, the kernel trick, and basically we enter into the space where into the field where you kind of do learning. What does it mean doing learning in this high-dimensional space? Yes. Again, so since today we are in the introductory class, so let me go briefly, or maybe no, I won't spend much time of it. So I guess you can, yeah. About learning, learning reflected to the techniques that we will try during the course. Memorization. Is it part of learning? Well, both yes and no. Yes, because I mean it's well, it's a valid learning mechanism, and for example, KNN, nearest neighbor classifiers rely on this, and nearest neighbor classifiers are part of this analytical reasoning. But what is missing with memory-based learning that we start with is really the absence of generalization. So, I mean, what we are good at as intelligent being, we are able to generalize. So we want to transition from a raw input to some kind of model describing a given phenomenon, or extracting a rule. So if then alike. So in this case, memorization, even though it is a valid mechanism, it's not really the learning we are up to. Memorizing rules, it's I mean, simply because I mean we cannot come up with all possible rules. It's not a valid mode for us. So what we want, as I said, we want to build models and maybe learn the meta rules to understand how a particular to explain a specific phenomenon. And here we are talking about so in the context of this course we are talking about supervised, unsupervised, and actually reinforcement learning is left outside the scope. I'm a little bit hesitating whether I should start something new or not. Maybe, it's a first class. I won't torture you with non-specific material. So let's finish for now. And next time we start with already technical content. So it will be a boot camp into machine learning, fundamentals of machine learning. Thanks for today. And I will put the recording online, so it will be available in Canvas and the PDF.
Thank you. Have a nice day.
Yes, bye.